Right, so we're going to have two strategies for verifying identities. Okay, and we're going to actually try out both of these strategies. Okay, and I would say that the first strategy here, which I'll read in a second, is going to be a little bit more helpful if we're working with a problem that looks a little less complicated. Okay, let's see what it says. Start off with the more complicated side of the equation. Then use algebra and known trig identities to end up with the other side of the equation. All right, so yeah, this is what we'll do with a little bit easier problems. Okay. This first one is not an easier one, but we're going to get it done using that first strategy. And the second strategy, when things do look a little bit more challenging, is what we'll do is we'll just start working from both ends of this. Okay. And is what I mean by working from both ends is I want to start thinking about what cosine squared of t plus 4 cosine of t plus 4 over cosine of t plus 2. I want to think about what else this is equal to. Okay. We actually, when we're verifying these identities, the whole point is we're trying to show that this relationship's true. We can't start off with this. And when I say this, I mean we can't start off by saying these two things are equivalent. Okay. And so the other thing we could do is we could take that other side, which maybe I'll zoom out just a little bit here. We start with this other side, the 2 secant of t plus 1 over secant of t. Well, we can keep simplifying both of these, and the hope is that they're eventually both equal to the same thing. Because if we've shown that they're both equal to the same thing, then we can conclude that they are both equal. Okay. And again, this will be the strategy that we'll usually want to take for the harder questions, maybe like this one. Okay. Because sometimes it's hard to connect the dots. Okay. Let's try out strategy 1 and we'll come back and we'll see why this strategy 2 here is a little bit easier. So remember with strategy 1 here, we want to start off with that more complicated side, cosine squared t plus 4 cosine of t plus 4 over cosine of t plus 2. And I want to justify to you real quick why I prefer to start with the more complicated side. I like to start with what I think of as the more complicated side because I think it's easier to simplify something than it is to make something more complicated. So here's our left-hand side. Now, we want to start using those trig identities from the first page so that we can conclude that these two things are equivalent. Okay. Now, there's one thing I'm actually noticing before really any of those trig identities that were up on that first page. And the thing I'm noticing is this numerator here kind of looks like a polynomial. Let me write it over here. Okay. Again, we have cosine squared of t plus, what was it, 4 cosine t plus 4. Now, this might remind you of something, which is, how about x squared plus 4x plus 4? Okay. And that's something you know how to factor. Well, these x's here are really just, in our equation up above at least, in place of cosine of t, right? which tells me if I wanted to, I could then factor this up here as cosine of t plus 2 times cosine of t plus 2. It's just instead of x's, I have cosine t's. Okay. Or how about cosine of t plus 2 squared? That would also be fine. Let's go ahead and write that over here. So we have cosine of t plus 2 times cosine of t plus 2 all over cosine of t plus 2. And so is what's going to happen here is cosine of t plus 2 divided by itself is just 1. So this will just turn out to just be cosine of t plus 2. Now we may have hit the point to where you might want to switch to strategy 2. Here's why. You might be looking at this and just have no idea how it's equivalent to 2 secant of t plus 1 over secant of t. That would be the perfect time to switch to strategy 2. However, we're going to follow through here. We're going to finish this. So this cosine of t plus 2, well, for one, it doesn't look like a fraction yet. And fraction is not quite what I mean here. I want to have something that looks like this. And how do we make that happen? We make that happen by being a little bit creative here. And what I mean is I noticed that expression that was up above, it had a secant of t in both the numerator and denominator. So maybe if I just try multiplying the numerator and denominator of what I have by secant of t, maybe that'll get us closer to what we want. Okay. And by the way, sometimes there's no way to know without trying. Okay. So it's okay here to try a couple different routes on these problems and not find the actual route we want to complete it until, we've tried and failed a few times. Now, if we do this multiplication here, see what we get. Well, we have cosine of t plus 2. I'm actually going to just write it. Cosine of t plus 2 times secant of t. And this is all over a single secant of t, right? I could divide the secant of t by secant of t right now, and I'd end up back with what I had, cosine of t plus 2. But we don't want to do that, right? We're trying to end up with something a little bit different here. In fact, this is what we're trying to end with here right now. Okay. Well, is what we could do is we can now distribute that secant of t. And you might remember, well, cosine of t is just 1 over secant of t, right? So if we go and we distribute this secant of t, well, secant of t times 1 over secant of t is just going to be 1. So we have 1 plus 2 secant of t, and then this is all over secant of t. And if we really want to be careful here and make it look exactly like this over here, well, the order of addition doesn't matter, right? The order of addition is commutative. So we could rewrite this then as 2 secant of t plus 1 all over secant of t. All right, and if your mind's a little blown right now, that is okay. This is a very challenging example. We will get better at this. We're going to practice lots more of these. And we're about to see a easier way to approach this problem, the strategy 2. Okay. Well, we could start off the same way. We could start the factoring. And next, we could divide a cosine of t plus 2 by a cosine of t plus 2. But before I do that, I'm going to move this thing down a little bit further. There we go. And so as I mentioned, one natural place, and there's more than one natural place here to get stuck, but one of the ones that's pretty common would be right here, getting to this cosine of t plus 2 and having no idea how to get here. Okay. Well, if we do have this happen, is what we'll do is we'll take the other end of the equation, and again, we are going to try and simplify it to actually any of these three expressions. Because if we can show that this right-hand side is equal to any of the three expressions above, then we know that 2 secant of t plus 1 over secant of t is equal to cosine squared of t plus 4 cosine t plus 4, all divided by cosine of t plus 2. Okay, so one actually common strategy when you do have a secant in your equation or a cosecant, it doesn't always work, but is to just rewrite it in terms of sine and cosine. Okay? And actually the same thing could be said about tangent and cotangent. Sometimes all it takes to simplify things, or at least see what to do next, is just rewriting things in terms of sine and cosine. So if we wanted to, we end up here. And the reason that this might be helpful here is you might be seeing that if I were to multiply the numerator and denominator by cosine t, I'd wipe out these 1 over cosine t's. Okay. And you'd want to do that just out of sake of simplification. Okay. But this might actually get us to where we want. So let's try it. I'm going to go ahead and just maybe write times cosine of t over cosine of t. Right, and if we distribute that cosine of t now in the numerator, we have 2, and actually just 2, right? Because the cosine of t times 1 over cosine of t will just be 1. Then plus cosine of t. And in the denominator, we have 1 over cosine t times cosine of t, which is just 1. And so that means writing over 1 is a little unnecessary. So we end up with 2 plus cosine of t. And I actually don't expect you to do this next part, but right, 2 plus cosine of t is equal to cosine of t plus 2. Again, addition is commutative when we're dealing with real numbers. So we have now shown that the right-hand side, let me point out what the right-hand side of the equation was. It was this. We've shown it is equal to something that the right-hand side of the equation is also equal to. Right? The left-hand and right-hand side are both equal to cosine of t plus 2, and therefore they are both equal. Okay. So we have verified this identity, and we verified it in 2 different ways.